Dear students, I hope you are all doing well. Today, in this video, we will discuss the Chlor-Alkali process. This process is used to produce sodium hydroxide, NaOH, on a large scale through electrolysis, which simply means breaking down of substance in presence of electricity. The process is called Chlor-Alkali process because it produces both chlorine, Cl2, and sodium hydroxide, NaOH, from sodium chloride, NaCl. In this process, salt, NaCl, is dissolved in water to make solution called brine, with two electrodes connected to a battery. The electrode connected to the positive terminal of the battery is called anode, and the one connected to the negative terminal is called cathode. A selectively permeable membrane is placed between the electrodes. When NaCl is dissolved in water, it splits into sodium Na positive and chloride Cl negative ions. Water also breaks down into hydrogen H positive and hydroxide OH negative ions. You will notice bubbles forming at both the cathode and the anode. At the anode, chlorine gas Cl2 is formed because Cl negative ions lose electrons, Cl negative ions to become stable. At the cathode, hydrogen gas H2 is formed because H positive ions gain electrons more readily. The selectively permeable membrane allows only sodium ions Na positive to pass while they combine with hydroxide ions to form sodium hydroxide near the cathode. In summary, the reaction happening in this process are: at anode, chlorine gas is formed, and each chlorine ion loses an electron, which means oxidation takes place. At cathode, hydrogen gas is formed, and each hydrogen ion gains an electron, which means reduction takes place. The overall reaction can be understood as NaCl reacting with water in presence of electricity produces sodium hydroxide, chlorine, and hydrogen gas. All the products formed in this process have important uses. Hydrogen gas is used as fuel and in the hydrogenation of vegetable oils. Chlorine is used as disinfectant in CFCs and in pesticides. The main product, sodium hydroxide, also known as caustic soda, is used in making soaps and detergents, in the paper industry, and laboratory as reagents, and for degreasing metals, and for many other purposes.